Okay, yeah. Should be ready. Thanks, sir. Hey, no problem.
Oh, India?
Yeah.
Look like?
Yeah, should.
Look like?
Oh, it's early, so.
Oh, we
No,
early?
About 7. No, here.
Here.
Here. Here. Hey.
Hello. Hello.
Chad,
Lamb.
nice to meet you.
Lamb, how are you?
Good.
Aw.
Happy New Year.
Happy New Year.
Hey, bro.
Nice to see you.
Good to see you again.
Yeah.
Nick not here yet?
He's here. He's running around somewhere.
Here he is.
Hey, bro. Happy New Year.
Happy New Year. Good to
Happy New
see
Year.
you.
Yeah, good to
Good
see you. Where's your father?
No, not yet.
Have you caught up with Mike Maxetti, who's running for
No.
Congress, I
No.
guess?
I don't
Seems like
think.
a sharp guy, but his campaign manager is a Vietnamese woman.
Oh,
She's handicapped, but she said that my grandfather always told me, fight the communists. You got to fight them.
yeah.
Empty customs. Yeah, but I was in El Toro, went over to Okinawa and kind of stuff.
Thank you.
It's still cheap, but you could still go out on 2 whole weeks, right?
Sandwich.
Yesterday? I hope you ate yesterday.
Yeah, I'm that close to the
Ăn trước cái đã. Thank you. Food?
Yeah, I'll grab it. But yeah, that's.
Coke.
About 3 years. Chicago. Okay. You don't know Chicago? The rest of my family.
7 giờ 7 phút. Ngày thứ Tư 28 tháng 1 2026. Đang ở Laguna Hill.
How everyone's doing today? Good? Yeah. Happy New Year. I'm glad to see you all.
Happy New Year.
Hope you had a Merry Christmas. Okay, so the topic of today's presentation is blockchain. Blockchain, why it is important? Blockchain is powering most, maybe all well-known cryptocurrencies like Bitcoin. And from time to time you can hear buzz about Bitcoin, Ethereum, and other coins, especially when price suddenly goes up or crashes. And these days there are several legislation which are in the works. For example, Clarity Act, the Genius Act. So they're supposed to clear some obstacles for I would say, day-to-day usage of this amazing tech. And what else? So I'm gonna, I plan today's presentation from the point of view of utility rather than like investing. I'm not gonna talk about how price behaves or when it was, how you can make any money, or we're gonna try to talk you into investing it. First I'm gonna explain how this technology works. I'm gonna talk about disadvantages, obstacles, frictions, and at the very end, I'm gonna talk about how we can use this for political activism, how we can crowdfund it. Okay, let's go. So usually when we do banking, or for example, if you go to a social media website, we deal with centralized systems. We do not realize it, but banks, social media websites, they owned by corporations. So it means they can censor you. Other alternative payment systems such as PayPal, Zelle, they are add-ons on legacy banking system, which is not much expiring, but they add convenience. So blockchain introduces, the difference between blockchain is it introduces decentralization. When you can hear from experts that blockchain automates trust. So what kind of trust it is? Trust means you can trust that you have your balance in your wallet, nobody can steal it if you do not share your private key, that you cannot do double spend, things like that. But there is no trust about monetary value. There is no trust that it's not going to be zero, its value going to be $0 tomorrow, or there's not going to, you cannot trust that the price is going to be the same. Because basically blockchains are just a distributed ledgers. So you can think of it as an Excel spreadsheet that lives somewhere in the cloud, and that's it. How blockchain accomplishes how distributed ledger is implemented is, for example, if you take a look at a centralized system like your bank, so your bank owns the servers. So when you open an account, first they do your checking account, then they create a record, which is your profile, and give you online access. On the blockchain consists of a loosely coupled network of nodes. What is a node? Node is can be any computer. If you think of a hardware, usually it's a server which is powerful enough to do so-called mining. In public blockchains, any node can enter the network at any time, and it can leave the network at any time. So there is no permission that you have to apply. So all you have to do is, as a miner, is you just download open source software, configure it, and run it. So this creates economy for people who own hardware. Compared, for example, the same economy that if you own a car, you can earn money as an Uber driver. So same thing here. If you own a hardware, you can loan it to the network, and network is gonna pay you in crypto. And this creates incentives for the miners, so miners stay within the network and keep it online. Since Bitcoin launch in 2008, so this model proven to be reliable, and it was running since 2008 non-stop without any interruptions. So if we take a look how it works, when you transact with somebody in Bitcoin or any similar crypto, you submit a transaction to the network. You sign it using your wallet and submit it to the network. Then miners, they start competing for your transaction. And your transactions end up grouped by blocks. Each block has a so-called hash. Hash is an important thing to understand because it's used as a rubber stamp a block. So once your transaction makes in the blockchain, then it cannot be removed. So all blockchains are immutable, although there are exceptions from this rule. Okay, so let's talk about hash. Hash, another synonym of hash is a digest. So I give you an example from the real world. So, for example, we have a conservative movement, and digest of a conservative movement was invented by Donald Trump, Make America Great Again. So you can think of it as a digest of the entire movement. For example, a digest of a nationalist movement could be, for example, as America First. And so let's imagine that there are some people infiltrate this movement, and some people, they say, oh, actually, Israel first. Yeah. So then digest automatically changes. It cannot be America First anymore. So it changes to sometimes America First. The same way here in the computer world. For example, you have any block of information, and you can do a digest, or you can run a hash from this block of information. And in computer world, it doesn't have any meaning. It just hexadecimal sequence. So it is very good to make sure that to enforce data integrity, that nobody tampered with the data. So, for example, in blockchain, every time, the way it works, that every time blocks gets generated every few seconds, but it depends on the network. The slowest one is Bitcoin. In Bitcoin, blocks are generated every 10 minutes. And even if there are no transactions, then empty blocks get generated. And each block has a hash. For example, it starts with block 1. The very first block in the blockchain is called a genesis. Any other blocks that get added later on, they have a pointer which points to the hash of the previous block. And this is how blockchain enforces data integrity, because it is designed to operate in zero trust environment. And since source of the software is available, it's open source, there could be any rogue miners that may try to alter that software and introduce a bogus transactions. For example, like submit a transaction when I spent $1 million and my balance is still the same. The blockchains are designed to prevent the situation, and another important part that miners do is they do transaction validation. For example, one miner wants to add a block. After this happens, then other nodes on the network, they submit a voting. So this creates a situation when, for example, there is a conspiracy among miners, and they all run, the group of miners decide to run rogue software. In order for this attack to be successful, amount of miners must be more than a half. So it should be 51%. And this type of attack is called a 51% attack. Usually there are tens of thousands of miners on major networks. And these scenarios are not viable because it's difficult for any group of rogue people, for any such conspiracy, to get a hold of the half of the mining nodes in the network. Okay, there are different types of blockchains, and one is proof of work, and second is proof of stake. Proof of work is the first type which was introduced, for example, by Bitcoin. In proof of work, the algorithm forces a miner to perform some artificial task, which is not really necessary to add a transaction to the block, but just to demonstrate that he did some work, and this needs to be, in order to be prevented, the flooding of the network with some bogus transactions. So, in other words, it's a price of entry to be a miner, because there are no other mechanism, because anybody can join the network, and there could be scenarios when a miner rents hardware and runs millions of processes that may try to overwhelm the network. So proof of work is designed to prevent this, but there is a price for that. So I explained you about a hash. Hash is a digest. You can run a digest of any data block, and you can come up with certain hash. But you cannot do it in reverse. You cannot tell the algorithm, hey, I want to produce this hash or digest, and there is no way to guess what the data should look like for that digest. This is how data integrity is achieved. So algorithm for proof of work works that the network introduces certain requirements for a digest. For example, if this is a sequence of words and numbers, it may ask, for example, let's enforce the rule that, for example, the third letter should be letter F and It should not be ABC, but it should be any other letter. And the miner starts guessing. It starts generating hashes by modifying a header of the block. It doesn't modify any transactions, but since you get quite different hash when you modify a header, so that miner tries to guess the correct hash, which can be approved by the network. So this algorithm is and it requires a lot of energy. Bitcoin consumes similar amount of energy comparable to countries such as Switzerland and Poland. And another type of blockchain is a proof of stake. Proof of stake is different, that there are no miners in the network, but there are validators. They do not do mining, but the price of entry is they have to have a certain balance of crypto coins, and usually it's about, I would say, $100,000. So they log this amount before validating, and if they submit the wrong transaction, for example, if they try to submit a rogue transaction, other nodes will reject it, and that rogue miner will be penalized by collecting a fine from his coins. So, example of proof of stake blockchain is Ethereum. Ethereum is a second major network. So they started off like Bitcoin with proof of work, but they moved to proof of stake in 2022. So usually proof of stake requires way less electricity, and you don't need expensive hardware, because what happens with proof of work, in order to be successful and make money from mining, you need to invest enormous money into the hardware, and it easily gets outdated, and you have to throw it away and buy a new one. Okay, next, wallets. So in order to start transactions in any network, you need to create a wallet. The major difference between your online banking account or PayPal is you can create a wallet without even connecting to the network. So this idea was very difficult for me to understand, because how do I create an account without connecting? In blockchain, the meaning of account is a wallet, is a public address. Public address is just a combination of numbers and digits. In order for you to have a control of that wallet, you need to have a private key. Private key is it's a longer sequence, but when you use that sequence with a wallet, so it unlocks your wallet, and then you can send coins anywhere. So it means you are in control of your wallet. There is a difference between wallets, so they can be connected to the network, and they can be disconnected. Usually, when you install the software on your phone, so it's a hot wallet because it's always connected to the network. And it is less secure because theoretically some hacker may hack into your wallet and send coins somewhere. Cold wallet is more, it's the safest storage available. So there are different types of wallets that are available. There are web-based wallets, for example, my Ether wallet. So it's just a static web page.
This video has been edited by iMovie Lord. Lamb Tram.